Hello everybody and welcome back to another video by Funlearn Tutorials. In this video we will be continuing with the Jones 1965 model. If you haven't seen the last video where I have explained the basic story of how an economy works under the Jones 1965 model, I suggest you watch this video first. I mean the previous video first. I will link it somewhere up here in the top right corner of the screen so that you can have a brief idea about how to build the equational structure, because you do not need to remember the equational structure. If you can understand the story of the model, then you will be able to build your own equational structure. So now that we know the basic story, let us now try to understand how to build the equational structure. When we build the equational structure for these types of models, we can think of two parts. One is we consider from the producer's side, which we'll be doing first. So let us first consider the producer's side. Now when we consider the producer's side, what are the two parts that come to our mind? We first have to buy the inputs. So we have an input cost, that is the one side of the coin. So we have an input cost, and the other part is we have to match it with the revenue. Then we can essentially consider a break-even analysis essentially. So we have a revenue and we have an input cost. Now again, going back to the assumptions that we had made in the first video, again let me just link it somewhere over here on the top right corner of the screen. Going back to the assumptions, we had assumed a perfectly competitive market, which means there is zero profit, that is there is actually no profit being made. So essentially the input cost and the revenue are the same. So we have to equate these two values and we have to find out some equations based on the producer's side. We are now concentrating only on the producer's side. Now let's go back to the two sectors, and let us first consider, suppose we consider the agricultural sector first. Let me just change the color, that will be better. So let me just consider the agricultural sector first. Let me think of the input costs. Here we introduce a notation. We use the notation Aij. Now what is Aij? Let me just explain that. Aij is called the input coefficients. So these values are called input coefficients. Now what do they essentially mean? That I can understand that it's a terminology, but what does it mean? It essentially means the amount of input required. Sorry, let me just correct that once. We'll just go down and we'll correct that. So it's the amount of input required to produce one unit of output from the sector J. Now which output? There are which inputs? There are two inputs, right? So we have to use I. So let me just explain that again. It's the amount of input I. So the first coefficient is actually the input, and this input has to be used to produce one unit of output from the sector J. So J is the output and I is the input, right? So that is how we define the input coefficients. Let me take one example, then it will become easier to understand. So let me assume that I want to produce the output of sector A. Let me call this sector as A, which stands for the agricultural sector, as I have mentioned in the previous video. So if I think of the letter ALA, ALA will mean the amount of labor, because the first letter is L, and I have mentioned that L stands for labor in the economy that we have assumed. So L stands for labor and A stands for agricultural sector. That means ALA is the amount of labor. Here input I is labor. So amount of labor required to produce one unit of output from sector A, which means one unit of agricultural output. So this essentially becomes, if I translate it to the definition terms, it becomes amount of labor required to produce one unit of agricultural product, that is ALA. Similarly, we can have other terms as we will be using in this video. The agricultural sector, let us go back once. The agricultural sector uses both labor and capital, right? So if I consider the agricultural sector first, as I have done here, ALA will denote the amount of labor to produce 1 unit of agricultural output, but it also uses K. So I'll also have a coefficient AKA, which is again amount of capital. So I am not writing it again, it's essentially the same thing. Amount of capital, so in place of labor we will have capital, amount of capital required to produce 1 unit of agricultural product. Again, since this is A, this agricultural product remains the same. Now that is true for agricultural product, but we also have a manufacturing product, which, as you can recall from the previous video, was my import competing sector as opposed to the exportable agricultural sector. So we will have these coefficients for the manufacturing sector as well. So we will have ALM, which will give me the amount of labor required to produce 1 unit of the manufacturing sector, and we will also have AKM, which will give me the amount of capital required to produce 1 unit of the manufacturing sector. So these are called the input coefficients. That is a new notation that we have introduced in this video and in this concept or topic, which is the input coefficients. So let me just highlight that once to remember. We have input coefficients. Now we want to frame the equations. So suppose we consider the cost part first. So if we want to see the cost, so ALA is the amount of labor required to produce 1 unit of agricultural product. If I want to produce XA amount of agricultural product, so suppose this entire sector produces XA amount of agricultural product. So this sector produces XA amount of agricultural product. 1 unit needs LA. So let me just write that down. 1 unit of agricultural in the agricultural sector, or let me just write that below as well. That will make it easier because there will be more space. 1 unit of agricultural sector uses ALA amount of labor. We are going by unitary method, so XA amount of agricultural output will require ALA into XA amount of labor. So that is the labor that is required, total labor that is required to produce XA, that is the total labor output, total agricultural output of the economy. So that means this labor that goes into this agricultural sector, this part that goes into the agricultural sector, part of the labor that goes into the agricultural sector, if I remove this part to make it clearer, this part is actually ALA XA. So this amount of labor goes into the agricultural sector, and the remaining part of course goes into the manufacturing sector, which obviously should be L bar minus ALAXA. But we will also give a formal another expression for this term that will make solving the equations easier. So ALAXA is the total labor that goes into the agricultural sector. Now this is the ALAXA that goes into the agricultural sector, but if I want to produce some amount of agricultural if I want to equate the cost and the revenue of the sector, I can consider it from the point of view of one output. So I can think that if W is the wage of 1 unit of labor, so W is the wage of 1 unit of labor, basically per labor unit wage, then I have to employ ALA unit of labor to produce my total output, or rather not total output, ALA amount of labor used to produce 1 unit of output. So my labor cost will be ALA into W. For every labor I have to pay W. So for ALA labor I have to pay ALA W. This is actually my wage bill. So this is the cost of labor input basically. This is the wage bill or the cost of labor input for producing 1 unit of agricultural output. Similarly, I can also have a capital bill or the cost of capital. So if I assume that R is the cost of capital, which is actually the interest rate, that is what is considered as the cost of capital. So if I consider R as the cost of capital, and I had explained that AKA is the amount of capital required to produce 1 unit of agricultural product. So for every unit capital we need R. So then for AKA unit of capital we will need AKA into R times basically that will be the capital cost. So I can write AKA R is the essentially the cost of capital input. This is the cost of capital input for producing 1 unit of agricultural output. Now do note that this is not like I can either use labor or I can use capital. As you can see from the arrow that I have put here, the agricultural output uses both labor and capital. You can switch between them. Of course there is some amount of substitutability, but it's not the total. It's not that I can produce all my output if I use this much amount of labor, or I can produce all my output if I can use this much amount of capital. These two have to be used simultaneously. So I am incurring this cost and this cost as a producer. I am incurring this cost and this cost simultaneously. So my total cost, so essentially my total cost becomes ALAW plus AKAR. So this is my total cost. That is total cost for 1 unit of output, right? So 1 unit of output cost is ALAW plus AKAR. Small recap, why are we considering that? To produce 1 unit of output I need ALA amount of labor. So for every labor I pay W. So for ALA labor units I pay ALAW. Similarly, for 1 unit of output I need AKA units of capital. For every capital I pay R units. So for AKA units of capital, too many A's. Anyways, for AKA units of capital I pay AKA into R cost essentially. So this is the total cost for producing 1 output or 1 unit of agricultural output. This is the total cost side. Now what is the revenue? If I consider the revenue, again if I consider the revenue from 1 unit of production, of course that will be the price of the agricultural output in the market. So we assume that to be PA. Now here again, going back to the assumptions that we had made in our first video, we had assumed that the economy is a small open economy. Here comes the significance of the small open economy. Since if this is the world, the economy is very small. Essentially that means that it's a agent of the perfectly competitive market. This assumption is related to the perfectly competitive market. It means that the economy, so if this is the economy and this is the entire world, the economy takes the price as given. That means PA is given exogenously. We cannot choose it. So PA is an exogenously given variable, exogenously given constant, and that has to be matched with my cost, right? Only then I can consider perfect competition. We have to consider it to be a zero profit condition, which means PA has to be equalized to ALAW plus AKAR, right? So PA has to be equalized to ALAW plus AKAR. That will give me one equation. So that is one equation. We can just a small homework that you can try. I will be explaining it in the next video. Can you find out that for the manufacturing sector, which is this sector, if you consider this sector, let me just highlight it. If you consider this sector, you will find out an equation like this. If you try to go by the same notations and by the same logic, can you try to find out PM, that is the price of the manufacturing sector, which will again be exogenously given. This PM should be equalized to, I'm giving the hints as I go as well. The manufacturing sector uses labor as well. So ALM, to pay for the labor it pays W, and it also uses capital in the manufacturing sector, and the capital's cost per unit is R. So this is going to be my second equation. Now can you try and find out logically how we'll get this equation? I'll explain this in the next video, so that it becomes clearer and we can understand whether we have essentially grasped the topic or not, and then we don't need to learn the equations anymore. If we understand the basic logic, we can frame these equations in the examination hall itself, and that will essentially give me my second equation. Thank you.